HVAC Temp Rise formula for airflow cubic feet per minute. How to measure heating only wattage correctly so your temperature rise calculation and cubic feet per minute airflow are spot on without inflated amperage from the blower motor or transformer. For electric furnaces and air handlers, the cleanest way to calculate airflow from temperature rise is to use the steady-state temperature rise across the heater and the true heat input in watts from the electric strip heater only. Measure supply and return air temperatures with a fast response thermometer or thermistor probes placed several feet downstream of the heater and upstream of the filter to avoid radiant and stratification errors. Then wait until readings stabilize for at least 5 minutes. Clamp your amp meter on each heat strip leg and record amperage per circuit, then measure voltage line to line at the same moment. Compute watts as voltage multiplied by amperage for each strip and sum the totals. Do not include blower motor amperage or transformer draw because they do not add heat in the electric heat section in a way that should be counted for heating energy. They add electrical load but not direct sensible heat input for the strip heater's rise test. Once you have watts, compute British thermal units per hour as watts multiplied by 3.412. Then compute airflow as British thermal units per hour divided by 1.08 multiplied by temperature rise in degrees Fahrenheit. If you are using multi-stage heat, test each stage separately with the corresponding wattage so your cubic feet per minute aligns to that stage's temperature rise. Seal off bypasses and confirm all registers are open to avoid false high temperature rise from reduced airflow. Cross-check results against blower tables and external static pressure to confirm your cubic feet per minute estimate is consistent with manufacturer data. One of the biggest mistakes in temperature rise testing and airflow calculation is including blower motor and transformer amperage in the wattage total, which skews the British thermal units per hour upward and makes calculated airflow in cubic feet per minute look artificially high. Fix it by measuring only electric heat strip amperage and voltage on the heater circuits and excluding the blower and transformer. One of the common errors in HVAC temperature rise diagnostics is taking temperature measurements too close to the heat elements or in the radiant line of sight, causing exaggerated supply temperature and misleading heating temperature rise. Fix it by placing probes downstream in mixed airflow and upstream in the return plenum away from the filter and any radiant surfaces. One of the frequent search engine optimization related issues technicians read about is relying on nameplate kilowatts instead of live measurements, especially when voltage is not nominal or strips are partially failed, which leads to airflow calculation errors. Fix it by verifying actual line voltage under load and measuring live amperage per strip, then recomputing watts before calculating airflow cubic feet per minute. BigHomeProjects.com lists vetted heating and cooling pros who know temperature rise testing, airflow measurement, and proper exclusion of blower and transformer amperage from heating calculations. Homeowners find trusted local contractors for maintenance, repairs, and replacements, while contractors showcase credentials, win leads, and book jobs with customers who value precise HVAC diagnostics.